In this video, we're going to learn how to solve problems involving critical points, minimum points, and maximum points of a function. And after going through this video, you'll be able to solve problems involving critical points, minimum points, and maximum points of a function. So ensure you stay with me till the very end of this video. I'm going to simplify it for you guys. Okay, so let's go into the details of this video. Now, let's look at this example I have here and solve it together. So example I have here says given f of x equals 2s cubed, okay, minus 3s squared plus 1. So we have to find the critical points of this function. Okay, now note that on that word for critical point is stationary point. So it's either you say critical point or stationary point, the two words mean the same thing. Don't be confused when you hear stationary point. It's talking about critical point as well. Okay, now note that at critical point, f prime of x equals 0. Now, in calculus, on that thing, I used to replace f of x is y. So either you use f of x or use y. So let me replace f of x with y here. That's y equals 2x cubed minus 3x squared plus 1. Right? Now, since at critical point f prime of x equals 0, that's the first derivative divided by the x equals 0. So the derivative of this function, the y over ds equals, so when you differentiate, they're going to have 6x squared minus 6x. When you differentiate the constant plus, when you give it 0 equals what? 0. Right? Okay, so now let's factorize this guy. When you factorize it, you're going to have 6x in brackets x minus 1 equals 0. So that means we are going to have two answers for the value of x. So when you equate them to 0, so what you are going to have 6x equals 0 or x minus 1 equals 0. So that's what you're going to have. Okay, so when you divide both sides by 6 to make the subject formula here, x will be 0. When 0 divides the number, it will give you 0. But this one, when this one cross over the positive sign, change to plus, now x is 1. So when x is 0, the critical point of x will have it to be 0 and 1. Alright? So now let's get the critical points of y. But before we do that, let's verify if we are correct, because at critical point f prime of x equals 0. So let's check if we're going to have 0 when we substitute these values in this derivative of it. So when you put 0 here and put 0 here, you still get 0. 0 square is 0. 6 times 0 is 0. So it still give you 0. When you put 1 here, 1 square still give you 1. 6 times 1 is 6 minus, when you put 1, it still give you 1. 6 times 1 still give you, so you are correct, guys. Now let's get the critical point of y. Since I got it for x, so that means we're going to substitute these values in this function and get it. So let's do it here. It's going to be when x equals 0, y equals, so let's substitute. You're going to have 2 in bracket 0 cubed minus 3 in bracket 0 square plus. So when you simplify it, you're going to have y equals, so everything I give you 0, okay, minus 0 plus 1. So everything else, the answer will give you 1. So 1 is the value of y when x is 0. So what of when x equals 1? So y will be 2 in bracket 1 cube minus in bracket 1 square plus 1. Right, so let's simplify them also. Y will be, when simplify this, we're going to have 2 minus 3 plus 1. So we will give you what's going to give us 0. Alright, so the critical points of y, we have them to be, our first value, we have them to be 1 and 0. So depends on how the examiner wants you to leave your value, what you have to find. When you have to find the critical points of x alone, so the values are just 0 and 1. If you ask to get the y alone, the values are what? 1 and 0. If you ask to get the both of them, so their critical points will be 0, 1, bracket close, and 1 and 0. This one is for x, this one is for y, respectively. Okay, so before we round off with this video, let's quickly look at how to find minimum and maximum points of a function. Okay, now guys, note that at minimum points and maximum points, that's what we use to verify it. We call it second derivative test. Now for second derivative test, that's when f double prime of x is greater than 0, the function is said to be minimum. Whereas when f double prime of x is less than 0, the function is said to be at the maximum point, respectively. Right? So that means yes, the y over dx of this function, let's do it again. This function here will give you 6x square minus 6x. Okay, so this is for the first derivative. What of the second derivative? The 2y over dx2, because we are making use of second derivative test. When you differentiate it further, you're going to have 12x minus 6. Okay, now note that we are making use of the critical points of x to evaluate the minimum and maximum point. Remember, the critical point of x, we had it to be 0 and 1. So let's check the value that will give us a number that is either greater than 0 or less than 0. So when x is 0, the function y will be, okay, so is substitute it here, 12 is 0 minus 6, which will give us what? Negative 6. And negative 6 is less than 0. That means we have our maximum point at minus 6. So maximum point of the function equals to minus 6. Whereas when x is 1, the derivative, second derivative, y double prime will be, okay, so let's substitute it. Sorry, let me correct something. Okay, we are good to go. So it gives you 12 in brackets 1 minus 6. So 12, so this will give us 12 minus 6, will give us was 6, which is greater than 0. This one is less than 0. So since it's greater than 0, this is the maximum, this is the minimum point, sorry, minimum point of the function. Why the maximum point of the function is minus 6, the minimum point of the function at x is 6. So guys, this is how you can basically find critical points, minimum points and maximum points of a function. I hope you learned something interesting. And with this, we are come to the end of this class.